Good evening, everyone. Am I audible?
Yes, ma'am.
Good evening, ma'am. Yes.
Good evening. And the screen is also visible, right?
Yes, ma'am.
Right. So I'll just wait for a couple of minutes and then we'll start the session, all right?
Ma'am, you are not audible. Hello.
I have not started anything. I'm just opening the screen. Okay, so we'll start. So week 3, we have quite some topics to see, but all of them are very simple topics only. So if you remember, we know that in week 2, we have already seen what are called frequency tables, right? And we saw this frequency tables for what kind of data do you remember in week 2?
Categorical data.
Yeah, so for categorical data, we have seen frequency tables, right?
Yes.
So in this week particularly, we are going to see various ways of summaries, graphical summaries or other numerical summaries, mainly for which type of data? For
Numerical data.
Yes, for numerical data. All right. So the way in numerical data, you know that how many types of data we are having in numerical type? So we have in numerical, we have discrete and continuous. Someone should mute. There is some echoing. Okay. All right. So we know that for numerical data can be further classified as discrete data and continuous data, right? So depending on whether the given numerical data is discrete or continuous, we will have the specific type of summaries. Okay, so let's see how far you remember what are discrete data and continuous data. So remember, a discrete variable usually involves a count of something, whereas a continuous variable usually involves a measurement of something. Okay, so can you quickly read this problem and tell me what's the answer? Read this question and tell me the answer.
B.
B.
Ma'am, B. Continuous.
Quantitative and continuous, right? Okay, good. Okay, what about the next question?
Quantitative and discrete variable.
Yeah.
Ma'am,
And what
quantitative and continuous.
see, whether we say 1 day, 2 day, we are not going to say 1.36 2 days or something like that, right? So
Pardon?
this is, see, either we say 1 day, 2 day, there is nothing like all the continuous means that all points in between should also be covered. But all points in between, does it make sense as a day? So maybe you can say maximum half day, but you cannot say what is 0.3 day or what 3 5 day. These things does not make sense, right? So how can you say it as continuous variable? It is discrete only, right?
Yeah.
Yeah. Okay. What about the next one?
Can you show the options? Only numerical and categorical is visible. It should be numerical. Wait a second.
Option C.
Okay, so note that more than one option can be correct in this case.
Okay, more than one.
So it is
A and
numerical
C.
and continuous, right?
Continue.
Yeah.
Yeah. A and C.
Okay, so now we have recalled what are numerical data and particularly discrete and continuous. Okay, now let's proceed with the summaries. So first we will see how to organize a discrete data. Okay, so organizing discrete data. So if the data set contains only a relatively small number of distinct or different values, there are not too many, only a relatively small number, then in that case it is easy to represent using a frequency table. So this kind of a frequency table we have already seen in the previous week also, right? So here, for example, consider this particular example. How many, so number of books read by 12 students in a month. So this data set contains how many books are read by these 12 students in a month. Okay, so here how many distinct values do you see? What are the distinct values you see in this data set?
12.
No,
No,
no.
1, 2, 3, 4. 1, 2, 0, 1, 2, 3, 4.
Yeah, so they are called the distinct values, right? Okay, now what is the frequency of each of this? What is the frequency of 0?
2.
1.
0
2.
is appearing
2.
1,
2.
2,
2.
2 times. How many times 2 is appearing?
2 times.
3.
3
3
times.
times 2.
1, 2,
2,
and 3.
3. Yeah.
So
Frequency of 1 is 1, 3 is 2,
1,
4 is 2.
2, and 3 is appearing 1, 2,
3
3
times.
times, and 4 is appearing twice.
2 times.
So the total is 6 plus 6, 12. Okay, so we have made the frequency table. Okay, so this is something which we have done earlier also. This is very simple. So the next type is a little bit different. Okay, so next we will be looking at how to organize continuous data. Okay, so to organize continuous data, so here what we have to do is that we have so many numbers here, data here. Okay, particularly numbers in this case. So if we have so many numbers, okay, we cannot put everything separately as an in one category, and then we put the frequency. That is not going to make sense. Suppose there are, let's say, 100, 200, or much more in real data, right? So we will not be able to put them as individual points, right? So in that case, we have to put them into some classes. Okay, so usually the number of classes are between 5 and 20. There are some certain kind of formulas also used, but here in this course, we are not going into the details of how to get the class formulas and all those things. Okay, so here we are just considering that maximum, minimum 5 and maximum 20. Usually, this is the approximate number of classes. Okay, and each observation should belong to some class, and no observation should belong to more than one class. So each observation should be there at least in not at least exactly in one class. Okay, and there is no observation which is not there in any class. So every observation belongs to some class. Okay, so usually we keep the class intervals of equal length. So what does these terms mean? Only if we see some example, it will be better. So further, without moving to some new terminologies, I will directly take an example, and with that, I will come back to this terminology again. Okay. So I will directly opening this example. So now in this example, so we have marks obtained by 50 students in a mathematics course. So here this is the data set, and these are marks out of 100. Okay. So just to observe, what is the minimum and maximum value? Can you check and tell me?
Maximum
What
is
is
98.
maximum is 98.
99.
Okay.
Minimum
90,
52. Minimum 52.
99 is the maximum, madam. 99.
99. I see 99 here. So
And 52
maximum
is minimum.
and minimum is 52. Is that correct?
Sorry, 50.
50. Yeah, I also see a 50. Okay, so this is just an observation, because we should make sure that all the values are covered in the intervals we are containing. Okay, so here we see that we have these class intervals. Okay, so these are called the class intervals: 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. So how many class intervals are we having here?
5.
1, 2, 3,
Five.
4, 5. So we are having 5 different class intervals. Okay, so this is the minimum number of class intervals usually we are considering, right? Okay. Now the next thing is that we have to make a tally of how many entries are between 50 and 60. But before moving to this, there is one important thing we should know. Okay, so now let us look at what the terminologies I was mentioning. So now take any class. What is the lower class limit? Lower class limit is the smallest value that could belong to a class. So for example, 50 is the lower class limit. Okay, and what is the, so for example, here you see 50 or 60. Okay, so upper class limit, here you see that. Okay, so here something I missed.
59.
Should be 50 to 60, 60 to 70. Okay. So for the upper class limit, the largest value that could belong to a class. Okay. So here there is one important thing. Everyone notice that. See, this is a rule we always using. What is the class interval inclusion? Okay. So a class interval contains its left end but not its right end. What does it mean? Suppose consider this interval 50 to 60. This means we are considering all points from 50 and not up to the entry before this. If you are mentioning it in terms of interval, then you can use something like this to represent it. 50 open interval 60. Okay, and 60 to 70 means it is representing something like this. So 70 will not be included in this class. Similarly, 60 will not be included in this class. Okay, so here for example, you see here the upper class limit is this and the upper class limit is this, because we are not including the last entries. Okay, and what is the class width? For class width is the lower class limit of next class minus lower limit of the current class. Take any two consecutive classes. Okay, consecutive means something like next to next. Okay, so you take the lower class limit of the next class minus the lower class limit of the current class. So for example, 70 minus 60. That is your class width. Okay, so these are some terminologies you should know. So main thing you should know about making the frequency table is that suppose you have 60, then where will you put? Whether in class 1 or class 2? If you have 60, where will you put? In class 1 or class 2?
In class 2.
Class 2.
Yes. Okay, only in class 2. Okay, so this is the important rule you should know when you are doing this frequency table. Now let's do it one by one. So first entry, where is it? 72. Here.
Class
85. 85.
Class 4.
Class 4. 56. Class 1. 98.
Class
Class
5.
5. 67. Class 2. 50.
Class 2.
Class 1.
Class
73. 88 here. If I'm making some mistake, let me know, okay? 95 in class 5. Where should 60 go to?
Class 2.
Class 2. 77 goes to class 3. 69 goes to class 2. 81 goes to class 4. 70 goes to
Class 3.
3.
68 goes to class 2. And then 57 goes to class 1. 93 goes here. 61 here. 52 here. 65. 79. Oh, sorry. 55. 83. 55. 63. 75. 58. 66. 71. 64. 59. 99. 78. 82. 60 again in class 1, right? And then 74 and then 53 and then 80. 80 belongs to which class?
4.
4. 67, 50, 68, 70, 76, 84, 91, 95, 81, 92. Okay, so the frequency, what is the frequency of class 1?
12.
12.
12. Class 2?
Also
Same.
12. The class 3?
11.
Okay. Class 4?
8.
8. Yeah. Class 5?
8 also, but you made a mistake, ma'am.
There is a mistake I have made. Yeah, it is 7, right?
7. Yes.
Yeah. So the sum is now 24 plus 11, 35. Yes, we have 50 now. The total is 50, right? So it makes sense. Okay. All right. So now you understand how to make a frequency table for a continuous data. Is that fine? Yeah. How to make this table? Is it clear? Okay.
Yes,
So
ma'am.
you are not asked to make any tables, so you don't have to exactly worry about how to make the class intervals or something. But it is good to know because these are the basics, right? Okay. So once you have this table, how to construct a frequency, how to construct a histogram from the frequency distribution we have. Okay. So first step is we have to obtain the frequency distribution of the data, which we have done. Okay. Second thing is draw a horizontal axis on which to place the classes and a vertical axis on which to display the frequencies. Okay. So we have to make a horizontal axis to place the classes and vertical axis for the frequency. So see, frequency is varying. Maximum is here 13. So here, I guess the data we actually got was 12 and 12, right? There is a mistake here. Yeah. So in that case, you see that I have a horizontal axis and a vertical axis. Horizontal axis is for classes, right? And then the next step is that for each class, construct a vertical bar whose height equals the frequency of that class. Okay, so what is the first class we are having? We are having the first class is 50 to 60. And then we have 60 to 70, 70 to 80, 80 to, maybe I'll write it in this way, not that much, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. Okay, so now corresponding to each class, I have to make a vertical bar whose height equals the frequency. So first class, what is the frequency? It is 12, right? So we have to make 12. So here, so okay, so approximately actually it should join here, so it is 12. So the next class is again 12. All right, and then the next one is 11, correct? So should be here. And then again it is 8 if I remember correctly, right? 8 and then 7. 8 and then 7. Okay, what is the important difference we should observe between a bar chart and a histogram? Okay, so note that there is no gap between the classes because this is representing a continuous data. Okay, continuous data means there should be no gap in the data, right? So there is no gap between the classes because this graph represents a continuous data. Okay, fine. So this side is the frequency.
Yes, ma'am.
Okay, all right. So label the bars with the classes, the horizontal with the name of the variable. Okay, and the vertical axis with the frequency. So this is done. Okay, fine. So we have now seen how to construct a histogram. So the next step is looking at what are stem and leaf diagram. Okay, so in a stem and leaf diagram or a stem plot, what are we doing? So each observation is separated into two parts. Okay, so namely a stem consisting of all but the rightmost digit. What does it mean? Except the rightmost digit, everything else should go to the stem. And
Excuse me,
a leaf, yes,
I just joined the class. Can you tell me what are the topics you have just covered, if you don't mind?
I have covered the frequency tables for discrete data and continuous data,
Yeah.
histogram, and then now we are starting stem and leaf diagram.
Okay, ma'am, after this session, can you repeat those topics
Please go and
after the
watch it in
session?
the YouTube. I cannot repeat, sorry.
Okay, ma'am.
Okay. In a stem and leaf diagram or a stem plot, each observation is separated into two parts, namely a stem consisting of all but the rightmost digit. Okay, so all but rightmost digit, what does this mean? Everything except digit at the right end.
Right, most.
Yeah. So everything except the right digit at the right end. Everything apart from that is stem. And the rightmost digit is the leaf. Okay. So for example, again, so now we have to consider each of observation as a stem consisting of all but the rightmost digit and leftmost digit. Only now we in this data we are considering. So it is just having two digits. So if it is two digit, it is going to be very simple. The tens digit here is the leaf stem and the units digit here is the leaf. Very simple, right? Now here what is step 2? Write the stem from smallest to largest in a vertical column to the left of a vertical rule. So here what is the next thing? We have to write the stems from smallest to largest in a vertical column. So here, first of all, what are the distinct entries for stem? What are the distinct first entries here?
1, 2, 3.
1, 2,
Yeah.
3,
So
4.
1,
1, 2, 3, 4. Okay, so
1,
these
2,
are the
3, 4.
distinct entries for stem. So this we should write it as a vertical in the vertical manner. In this way, we have to write. First, this is the first step 2 given to you. Okay, and then write each leaf to the right of the vertical row in the row that contains the appropriate stem. Okay, so it means what? For example, now this is my stem. I'm going to write the leaf part. Okay, so for example, the first data 1, 2, 2 is the leaf, so I will write here. And then 8 is the leaf, I write here. And then here 1 is the leaf, I write here. 7 is the leaf, I write here. And then 3, 4, 4 is the leaf, I write here. 9 is the leaf, I write here. And then 5 is the leaf, I write here. 2 is the leaf, I write here. Again 1 is the leaf, I write here. 9 is the leaf, I write here. And then 46, 6 is the leaf. 23, 3 is the leaf. Okay, and very important step, the last one, arrange the leaves in each row in ascending order. Okay, we should not stop it with this, we should arrange them in ascending order. So here, stem and leaf. So one, first, you see this row, everything is already in order. What about the second row? Can you say it in ascending order?
No, ma'am. It should be 1, 3, 5, 7, 9.
Yes, ma'am.
1, 3.
5,
5,
7,
5,
9.
7, 9.
Okay, and then
1, 4, 9.
see, this is a good practice to write. So just observation here. It is a good practice to note that I'm writing like one entry here, like in this fashion I'm writing. Okay, so just a very important observation. Okay, this is how usually it is done. All right, and the last one, it is already in order. Okay, so this is the stem and leaf plot, which is required books. Okay, so why this order which I was mentioning is important is that, so if you just turn it uh, and see, or if you want to be just show, suppose just an imagination. Okay, so if you make a histogram, it would have looked something like this. Okay, so you can also visualize the stem and leaf histogram
Wow.
roughly from the stem and leaf graph. Okay, the same thing, if you had made a histogram, it would have looked like this. Yes.
This image is really cleared the concept.
Okay. All right. Good. So now continuing further. So we have seen the graphical representations of how to summarize the given data using some graphs, right? So the
Hello,
next
ma'am.
thing, yeah.
Uh, when I have 3-digit number, then stem and leaf, how would I
3-digit,
represent?
4-digit, everything can be done in the same technique. So suppose you are having, maybe I'll use a different color to differentiate. Okay. Suppose let us say my data consists of all the year of year of a class of 10 students. Okay, so in that case 4 digits will be there, right? So for example, let's say 2001, 2005, 2010, 2003, 2000, something like this. You have so many other data also. So here you take 2000, 2000. So for example, even 19 something is also there, let us say. So 199, and then 2000. So not 2000, everything 2000. So suppose 201 is there, yeah, we have to write 201. And then 2020, of course, will not be there in our class. So we have only 3 stems, and then you write this leaves here. 2, 0, 1, 5, 3, and so on. Okay, you understand?
Yes, ma'am. Only one digit should be in leaf. No?
Yes, yes. Okay, so maybe I'll stop with 5 students, otherwise the question may look incorrect. Okay, fine. All right. So now continuing further. Okay, so now we are going to look at descriptive measures. So these descriptive measures are quantities whose values are determined by the data. Okay, so the most commonly used descriptive measures are measures of central tendency and measures of dispersion. Okay, so these two things are very important to understand the data together. Okay, so for example, let us say in a class, okay, before going to the definitions, in a class there are, like, let's say 100 students are there. Okay, so usually what is the average score taken by a student is asked, right? So average score tells about kind of a mean value, right? It's a middle value kind of thing, right? So usually the average score is taken, so that is a measure of central tendency. But also you see that, so who has scored the highest mark, that is also asked, right? And also who has got the lowest marks, that is also asked. Okay, so it is not just the measure of central tendency, just the center, which is what we need. We also need the measure of dispersion, which tells us how much is the data spread across. Okay, so that is also is very important. Okay, so we start with measures of central tendency. What are the three measures of important measures of central tendencies in general? Do you know? Most of you already know, right?
Median and mode.
Mean,
Yeah.
median, and mode.
Very good. Okay. So here the mean of a data is the sum of the observations divided by the number of observations. This I guess everyone already know. There is nothing new. So this is just the usual average we say, right? So here remember in week 1 you have already seen what is a sample and what is a population, right? Sample is usually represented with small n and population is usually capital N. So here, so we have some sample mean and population mean. So here, while taking the average for sample mean, the number should be small n, and for population it should be capital N. Okay. So this is just the sum of all the entries divided by the total number of entries. Okay, this is the mean. Okay, so very simple example. Can you all quickly find the sample mean for this? So how many entries are there, first of all?
10.
Yeah, so here we have 10. So x1, x2, x3, everything you have to just add them up. So if you add, what are you getting? Can you quickly compute and tell me?
$68. I
680.
mean, 680. So the mean would be 68.
680 by 10.
Yes, ma'am.
680 by 10, so 68. Okay, good, very good. Okay, so next is mean for group data. Okay, so we have seen how to calculate the mean for discrete data. So not discrete data, I mean single data. So next we will see for group data. Okay, so what is group data? So suppose instead of values given separately like this, now suppose we have a frequency table representing the data. Okay, so here you have 1 repeating twice, 2 repeating 3 times, 3 repeating 5 times, 4 repeating 4 times, and 5 repeating once. Now how to compute the mean? So instead of doing 2 plus 2, instead of doing 1 plus 1, I can also do 1 into 2, both are same, right? And instead of doing 2 plus 2 plus 2, I can do 2 into 3. That is also same. So that is what we are doing here. So instead of just adding up, we are just multiplying with the frequencies. Okay. So we are doing 1 into 2 plus 2 into 3 plus 3 into 5 plus 4 into 4 plus 5 into 1, 5. So the sum of all this, which is 44. Okay, 44 divided by, what is the frequency?
15.
15. Okay, so what is the value actually here?
2.94.
2.933.
2.933.
2.93, right? Yeah. Okay, fine. So you see that instead of doing this, we have did this to get the mean. So you understand the way why we are doing this? Okay, all right. So just to simplify the process. Okay, now if we are having a group data for continuous data, earlier it was discrete, now it is continuous. Okay, so for example, here you see that we are having 50, 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. Okay, and these are the frequency given to us. Now for this frequency, first of all, we have to find what is midpoint. What is the midpoint? For midpoint, you have to do 50 plus 60 divided by 2. What is it?
55.
55.
55.
55. Same way, what is the midpoint for the next class?
65.
65, 75,
Next.
75, 85.
95.
Okay. Now, can you all calculate Fi into Mi quickly?
605.
Okay, so it is 605.
845.
It is actually 12 in our data on both the data, right? But it's okay, as long as you understand the concept, it should be fine. 13 into 65 is 845. And then 11 into 75, how much is it? 825. 8 into 85. And then at last 90. Can you all tell the sum? What is the sum? What is the total?
3620.
3620.
3620.
Okay. So according to the formula, x bar is 3620 divided by n is 50. So what is the answer?
72.4.
72.4. Okay. So here something important is there. Note that here, see, earlier what we did, we just multiplied each of the frequencies with the actual data. But here we are not multiplying the frequencies with the actual data, but just the middle point, something kind of representing the center of the data present there. Okay. So here, for example, in this class, maybe we had 52, 56, 58, 59. So this kind of data were there in this class. But instead of multiplying every entry into the actual frequency, here what we have done, we have just taken the midpoint and multiplied with the frequency here. So because of which this is not the actual exact value of the mean, but it is an approximation. Okay, so this is an approximation. This is not the exact value, but that is okay. This is enough for the most of the cases. This approximate value is enough. Okay, fine. Okay. So next thing is that what happens when you add a constant to all the entries of a data. Okay, so these are all the entries. Now these are the scores obtained by a students in a quiz. Okay, suppose the teacher add 4 marks to each student. How is the old mean? Okay, so first of all, this is your original data. What is your new data? What is your new data? When you have to add 4 to each student. So what is your new data?
59. 66. 52.
59,
74,
56, 52,
74,
74, 69, 64,
62.
62,
No,
70.
no, ma'am.
Am I
Ma'am, you
making a
did
mistake?
mistake there. Yes, ma'am.
Where? Where did I make mistake? 64 and 62, right? Plus 4 plus 4.
Yes, ma'am.
It's fine only, right?
Yes, ma'am. No mistake.
76 and then 67 and then 71. Now this is the new data, right? First of all, what is the mean of this existing data?
62.
Okay, so is it 62 for everyone? Did you all calculate? Can you all quickly check what is the mean? It's 62 only, right? Yeah? Okay,
Yes,
so
ma'am.
this is the old mean. Now for the new data, what is the new mean? Compute it and tell me.
248, I guess.
Yeah. So what
248.
is the sum of all the entries?
66, I think.
It is 66. So
Yeah.
you got
Okay. 62 plus 4 equals to 66.
660 by 10, so 66. So what is the thing we have seen? So your new mean is equal to 62 plus 4. So new mean, so this is the C constant is old mean plus C. Okay, so if your yi is xi plus c, where c is a constant. Okay, so these are your xi's and these are your yi's, right? And here c is 4. Now, what is the new mean? New mean is old mean plus c. Okay, so your y bar is x bar plus c. Okay, fine. Now, we'll do a similar thing for multiplying a constant. Recall the marks of the students. So, these are the marks of the students. We already know what is the mean. So, the mean is 62, right? The mean is 62. Now, suppose the teacher has decided to scale down. Earlier, the teacher was in a good mood. Now, he or she is in a bad mood. So, now scaling down each mark by 30%. Okay. In other words, each mark is multiplied by 0.3. Okay. So, now what is the new data first of all? What is the new data? Can you all calculate and tell me?
16.5.
Okay. So,
Then 18.6.
16.5. Yeah. 14.4, 21. If some values are wrong, please let me know. Okay. Now, what is the sum of all these entries? So, suppose these data are represented by yi. So, your y bar is summation yi by 10. So, what is your summation yi?
$78, I guess.
How much?
It will be 180. 50.
18.6.
Ma'am, it is 186 by 10, so 18.6.
186 by 10.
Yes, ma'am, so 18.6.
Okay. Okay, so you observe that this is 62 into 0.3. Right? So here again, what is the observation? The observation is that your new mean. So if yi equal to xi into c, so your new mean, which is y bar, is equal to old mean x bar into c. Okay. All right. So next, moving to what is called median. Okay. So median of a data, we have already seen median and mode for categorical data. So the similar concept is here for numerical data as well. So median of a data set is the number that divides the bottom 50% of the data from the top 50%. Okay. So the median of a data set is the middle value in its ordered list. Okay, so what are the steps? So first thing, always, this is a very important step. Don't forget this step. So arrange the data in ascending order. Many people forget this step. This is important. Okay, and if n is the total number of observations, then if n is odd, then you look at the middle value, which is n plus 1 by 2th observation. And if the observation is even, then you have two middle observations. So n by 2 and n by 2 plus 1, two middle observations. So now you have to take the mean of these two. Okay, so earlier it was categorical, so we just took both. But now we are in a numerical scenario, so we have to take the mean. Okay, so let's look at this example. So median, so first we consider an odd scenario. So data in ascending order. Yeah. Can you tell the data in numeric in ascending order, given data?
Ma'am, 45, then 50, 55, 60.
55, 60, 65, 70, 75.
Yeah. Okay. Next, to find the middle value, how many number of observations are here?
7.
7.
Okay. So if 7 is there, we know the median position is
60.
N plus 1 by 2.
so fourth position. What is there in the fourth position?
60 plus
60.
55 by 2.
No. We are in the odd scenario. We are not in even scenario. Don't get confused.
4, 5, 6. Okay, sorry. Actually, ma'am, sorry, I have noted only 6 data pointers. Sorry.
Okay. So the next example here you see is the median for even number of data. Okay. So here you see we have 8 data given here. Can you tell the data in ascending order?
18,
Hmm?
20, 22,
22, 24,
4, 25,
27,
28,
28, and
30.
30.
Okay, good. Now the number of observation is even. So what are the middle positions? N by 2 and n by 2 plus 1. So it is 4 and 5. Right? So what are the values at fourth and fifth position?
24 and
24 and
25.
25. So you take the average. 24 plus 25 by 2. So which is 49 by 2. So what should be the answer?
24.5.
24.5. Okay. So what happens when the data is odd and when it is even? How to find the median? Is it clear for everyone? Yeah. Okay. So let's
Uh,
look at a comparison of data, this mean and median here. Okay, so now we are having two different data sets. Okay, so here the first data set you are having some values. Can you all quickly compute the mean and median? There is something wrong here, I guess. Data ends with this. Just a minute, sorry. So just this is not there. Okay. So the data is arranged in ascending order means you have 2, 3, 5, 6, 7, 7, and 12. Is this correct? In ascending order? So this is the median. So you have 2, 3, 5, 6, 7, 7, 170. So this is the median. What is the mean in the first case? Did you all compute?
6
It's
is the mean.
6. 6 is the same.
Okay. And here, what is the mean? Yeah.
I think 6, ma'am.
For second data also it is 6. Are you sure?
Let me check again, ma'am. But
21.
147 divided
Should
by
be
Ma'am, it's
21.
21.
21.
21.
Yeah. So this is the difference. So here you notice that only one value has changed. So only one value is different in data set 2 compared to data set 1, right? So but then even for the one value the mean has changed, but the median is remaining the same. Okay, so here what we call something called outliers. I guess you all already know what are outliers. They are values in a data set that are very different from the rest of the data. They are unusually large or small observations. So here, for example, this is an outlier because it is unusually large compared to the other observations. Okay, so the sample mean is sensitive to outliers. What does it mean? So if there is an outlier, the mean will change drastically. Okay, what does this mean? This means that an outlier will change the mean drastically. Okay, whereas the sample median is not sensitive. So it means what? So not sensitive means it does not change. Not sensitive means it does not change or does not change much, we can say. Okay, is it fine? All right.
Yes, ma'am.
Okay.
Ma'am,
So yeah,
ma'am, like this median, this median is defined for continuous data.
yes. The
Okay,
same
continuous
definition works for
means,
continuous data as well, right?
ma'am, continuous means what I want to say is that 50 to 60, 60 to 70, those kind of data.
Oh, that is called grouped data.
Okay,
Okay.
grouped data. Yeah, ma'am.
Yeah.
Is it defined, this median?
Median is defined, but I guess in this week we are not covering it. I don't know even if it is covered in a later week, but it is not here. It is defined.
Okay, okay. Okay.
Okay. Okay. All right. So what happens to the median when we add a constant? Okay, we are looking at the same data set for the same problem. So already we have the data set, right? So the data set. So he asked, suppose if we are given a group data instead of single value data, how do you find the median? Is it defined? It is defined, but we are not covering it in this week. I don't think it is covered also. Okay. All right. So not old data. This is the old data we have, and the new data. What is the new data? So it is just plus 4. So 59, 66, 52, 74, 69, 64, 62, 76, 67, and 71. This is the new data. Now for this new data, what is the median? Again, we have to arrange them in increasing order. Already we have computed the median for this data, right? What is the median for this data? Where was it? This one? Was it this one or something? No, we did not compute the median. No. So maybe it's a good idea to write the new data after rearranging in this way. Okay. So let's arrange them in ascending order. What is that we will get? 48,
55, 58, 60, 62, 63, and 65, 67, 70, 72.
So our new data is 52, 59, 62, 60, 64,
66.
66. 66 and then 67, 69, 71, 74, 76. Okay, so the number of entries have not changed at all. So whether in the first case also it is 10, now also it is 10. So n is equal to 10. So if it is even, you know that you have to consider n by 2 and n by 2 plus 1. So we have to consider fifth and sixth data. So what are the fifth and sixth data? So here, did I miss any values? 4, 5, 6, 7, 8, 9 only is there. I missed some data. 62 and then 64 is missing, right?
67. Sixth value 67, right?
1, 2, 3, 4, 5, 6. Yeah. So these are. And here it is 4, 5, 6. Okay. So old median is 62.5. New median. What is the new median?
66.5.
Okay. So what is the difference between new median and old median?
4.
So new median equal to
Old
old
median
median plus 6.
plus C.
Okay. All right. Okay. So a similar observation can be done here. So what is your guess about the medians? Do we already have the data? So when you multiply by 0.3, what is the data we have? It is 16.5, 18.6, 14.4, 21.0. So 19.5, 18, 74, 17.4, 21.6, 18.9, and 20.1. Okay, so if I make, so already I have computed the median, which was 62.5, if I'm correct, right? Yeah. Now, for this data set, again, I have to arrange them in ascending order. Can you tell me in ascending order? Where do we start? 14.4, right? Is that correct? Then 16.5, if I'm
Ma'am,
correct.
shouldn't this be multiplied by 0.6?
That's what we are checking here. Okay, so whether that is how it is working, just a quick check with an example.
Okay, because they told it's scaled down each mark by 30%, so it's decreased by 0.3. I mean 30%. So the remaining will be 0.6, right, ma'am? Multiplied by the value.
Sorry, I don't understand.
Sorry, I mean
What is the
0.7 by the value. Here is mentioned that the teacher has decided to scale down each mark by 30%. So each mark is reduced by 30%. So when
yeah?
each mark is reduced by 30%, the remaining new mark for each person will be 0.7 multiplied by the mark rate, ma'am, not 0.3.
Okay.
Because if you multiply by 0.3, that means it is scaled down by 70%. That is scaled down or reduced by 70%.
Yeah, I got it. So it is actually 15 minus 16.5. The data is actually 55 minus 16.5. It should be something
Yes,
like that.
ma'am, that's how it should be. Ma'am. Here the terminology, in other words, each mark is multiplied by 0.3, no, it should be 0.7.
Yeah, I have made a mistake here. So, thank you for pointing out. So,
Or
if
instead of
again,
changing all this, ma'am, we can simply change that 30%
question
to
we will
70%.
change. Yeah, we'll change the
30% to
question.
70%.
Yeah. Thank you. That's a very important thing, right? So here we'll change
No
it
problem.
to.
No, ma'am, when we change it by 70%, it will be 0.3.
Okay, just this we are changing, right?
Yeah, either one should be changed.
Yeah. Okay, good.
Yes.
So again, the same thing happens here as well. Okay, so this is now. Oh, the other way around. I should have made there.
Yes, ma'am, we need to change it the other way around.
Yes, ma'am.
This
Yeah.
That should be 70% and it should be 0.3.
Yeah. Okay. Good. So here, yeah. So where were we? So 16.5 and what's the next value should come? 17.4. Is that correct?
17.4.
18.
18, 18.6, 18.9, 20.1, or 90. Oh, okay.
Then
20.1.
21.6. Is that correct?
No, 21 is there.
20. Yeah. Okay.
21, 21.6.
Oh. So now, again, what is the median? So median is the average of the fifth and sixth value. So here, new median
18.7.
18.6 plus 18.9 by 2. So what it should be?
18.7.
18.75.
That is better. Okay. Right. So now we have 18.75. So here what happens? What is your old median?
62.5.
Okay. So here you have got this is 62.5 into 0.3.
Yes, ma'am.
Okay. So this means we have got new median equal to old median into C. Okay. All right. Good. Now moving to mode. Mode is the easiest, right? Most frequently occurring data. So if no value occurs more than once, then the set has no mode. Okay. So for example, in the first data set, can you find the mode? 4 occurs 3 times, 7 occurs 2 times, 9 occurs once, 6 occurs twice, 2 and 3 occurs once. So what is the mode?
4.
4.
Okay. What about the second data set?
No mode.
No more.
No. Okay, good. Okay, so again, I don't think it is required to do this constant adding every time. Okay, shall I leave this as a homework? Otherwise this might get boring, I guess. Is it okay if I
Yes,
Yes,
skip
madam.
this?
Yes, ma'am.
Yeah, so this I'll leave it as a homework. Okay, it is very monotonous otherwise. Yeah, okay. Okay, so next we are moving to measures of dispersion. Okay, so now why do we need a measure of dispersion? So dispersion means, first of all, what does it mean? How far the data is spread across, right? So consider the two data sets given below. So first, yeah,
Sorry for the disturbance. I just joined. Actually, I have one question on just before added constant. Practically,
hmm.
what is the use of this added constant? Generally, where we use it? I mean, so what is the application?
See, adding constant or multiplying a constant definitely will make sense, right? Suppose, let us say that you are see, a very simple example, whatever we considered here is also making sense. Same way in a huge data set also, it is possible that due to some, let us say the machine was doing the readings, and then there was some zero error, and because of the zero error all the observations had to be added some 3 values or 5 values or whatever. That is definitely possible, right? Yeah.
Uh,
So we can,
yeah.
yeah, so this kind of things are naturally happening, that we may miss something, we may have to add or even subtract,
Yeah,
and we
multiplication
have
I
to set it.
understand for the scaling and all, but addition I'm not understand actually where we use it. If you have any general some example, can you explain or you can?
That is what I said. When you are doing this, for example, taking the measurements itself, you have the measurement data, but then you later notice that in the caliber of that whatever device you are using, there is a zero error. So it means
Okay,
whatever measurements you are taking, either +3 or -3 or plus C or minus C might have happened because of the zero
okay,
error, right?
okay.
So yeah,
Yeah. Thank you.
yeah. Okay, so next we are looking at measures of dispersion. Why do we need a measure of dispersion? Okay, so consider these two data sets. The first data set is just everything is the same 3, 3, 3. Second one is 1, 2, 3, 4, 5. Okay, so now we are looking at the mean, median, and mode. For first data set, obviously everything is the same. And for the second data set, the mean is 3, median is also, sorry, are there any questions? Okay. So the median is also 3 and there is no mode, right? So these two data set, what is that we observe? The mean and median are same for both data sets. Okay, but the data sets are not same, they are different. Okay, so how this difference can be defined quantitatively? Okay, so for that we need something called a measure of dispersion. Okay, so it is either called measure of dispersion or measure of variation or measure of spread. How far it is spread. Okay, so for example, suppose let us say this usually this diabetic patient, they are checking the blood sugar level, right? So they have something called the average level. But also suppose there is some too much up or too much down going for that patient. Okay, so usually they should also know what is the range in general. Is it going too low or high? So in that case, measure of spread is also very important. Okay, not just the average, not just the middle value. Measure of spread is really important to understand the nature of that particular instance, right? So what are the different measures of dispersion? Range, variance, standard deviation, and interquartile range. So these are the different measures of dispersion we are having. Okay, so we'll see one by one. Range is the most simplest one. Okay, so the range of a data set is the difference between its largest and smallest values. Okay, so very simple, maximum minus minimum. Okay, so if you have, for example, data set 1, so here you see that range is 0. What is the range for the second data set?
4.
4. 5 minus 1. 4.
Okay, so again, range is also sensitive to outliers because, for example, see only one value if you are changing. Now this is an outlier. Now because of this, the range is going to change drastically. So the range for data set 1 is 4 and the range for data set 2 is 24. One value changes and you see the range has changed a lot. Okay, and one value is not just one value and it is an outlier. Okay, so outlier affects the range. Okay, all right, so the next one is variance. What is a variance? Okay, one way of measuring the variability of a data set is to consider the deviations of the data values from a central value. Okay, how far it is deviating we have to understand. But how far it is deviating from where? So usually this is a common technique. We see how far it is deviating from a center. Here that center is the mean we are considering. Okay, so from the mean, how far the given data set is varying. That is what we are considering. Okay, so here population variance and sample variance is there. So you have two data set here. Sorry, two different variances, just like we had it for mean, sample mean and population mean. Same way here we have for variance as well. So we have two different formulas. So here you see that these are the formulas we are given for finding the variance. But before finding the variance for this particular example, can you find the variance for this 1, 2, 3, 4, 5? Can you all find the variance for this data set 1, 2, 3, 4, 5?
Ma'am, which variance? Sample or population?
Both.
Okay. So the population variance is 2.
Mm-hmm. Yeah. So you get the population variance as 2,
Yes,
right?
ma'am. Yes,
So
ma'am.
now do you see that this helps us to understand how far are the extreme values from the middle values? Do you see? Yeah.
Yes, ma'am. Okay.
So this is what variance is telling us. How far are the values in a data set from the middle value? Okay, that is given by the variance. So this data set is a very
It is
simple
after
data set
arranging
to
in the ascending
understand it.
order, right, ma'am?
Yeah. To visualize it, yeah, we are arranging in ascending order.
Ma'am,
Yes.
how far means how far is the this border values, right?
Yeah. So to what extent can we go to the left as well as to the right? So for in the left, I can go up to 3 minus 2, and in the right, I can go up to the data set goes up to 3 plus 2, something like that. Approximately, I'm talking.
Okay. And this will be applicable for any type of data sets, right?
Yes, you can
Okay.
check that.
Okay.
Yeah. Okay, so now this small example I just told you to do to understand the underlying meaning of variance. Okay, so now you can do this problem here. Everyone do this. Find the variance of this given data set, both population and sample. So first of all, what is the mean? We have already computed the mean, right? What is the mean?
I think 62.
62.
Yeah, so the mean is 62.
But I guess you can scroll up and check now. It can be 62 or 62.5.
Yes,
Mm,
62.5 was there.
No, I think it is
okay.
62
Yes,
only,
no. So I
madam.
feel you can just scroll up and just recheck.
My eyes are hurting. Yeah, where was it? Where?
It's below, madam.
Yeah,
Yeah,
yeah. It's 62.
62 only.
Okay. Okay.
Yeah. So if it is 62, so how do we calculate the deviation from mean? So what is this here? So this is x minus xi. This is x minus xi square. So it should be
7.
7.
Minus 7.
Okay. So I guess the formula here is xi bar minus, right? Sorry, sir. I should have written the way it is given here in here. So xi minus x bar and then xi minus x bar square. So minus 7, 0, minus 14, 8, 3, minus 2, minus 4, 10. Did I miss any value in between?
No. No.
No. There is some mistake here.
Minus
55, 62,
Yes, ma'am.
48, 70, 65. Then 60 I have missed here. So
yes.
from here it's so it is 60.
Madam, we can write at the end also, right? No need to cut and write.
Yeah, that is fine. I just
It won't affect the
filled
order,
it
right?
from my yeah, we can do it. Not a big deal. Yes. We can do. So I can just take the last value. What is the missing value? 60, right?
60, yeah. Okay.
60.
60 is the missing value. So 58 minus 4, then 10, 1, 5, and this one is 2. Okay, now you just need to square them up. So if you square them up, what is it you are getting? Okay, so now what is the sum of all these values? Please mute.
464.
464. Okay, so what is the population variance and what is the sample variance in this case?
Population variance is 46.8.
464 by 10.
Sorry, it would be 46.4.
Yeah. And sample variance?
51.56.
Okay. All right. So we have understood how to compute the variance. Okay. So again, someone's
Hello,
noise is
ma'am.
disturbing.
Madam, can I ask one doubt?
Yes, yes.
Actually, if you see in the simple example, you told like
Hmm.
we got the something at 3.
Mm-hmm.
So we were saying that our data is kind of, 2 right and left. But here
Mm-hmm.
it's not fitting right. If you see, it's 46.4, which
Mm-hmm.
is in the extreme kind of towards left side, right? Not at the center.
See, that is the problem with variance. So later on, we will be fine tuning it. So this is not a fine tuned one, but this
Okay,
tells
okay.
how far, like what is the maximum or minimum we can expect. It cannot definitely go beyond that. Okay, it will not definitely go beyond this point. Okay,
Ma'am, how you
right.
compute simple variation? Sample variation.
Sorry, what?
How you compute sample variation?
Oh, so here you divide 464 by 10. Here you divide 464 by 9. So this is 464 by 10. This is 464 by 9. Just n minus 1.
Someone please mute.
Okay, ma'am.
Okay.
Zishan, please mute yourself.
Okay. Okay. So now moving again further. So again, this is again adding constant and multiplying constant. But here something is important. Adding a constant is not going to change your variance. Can you visualize why is that happening? So suppose some data is increased by 5 or decreased by 5. The variation is going to
If it is
remain the
increased by
change, right?
5, then the mean will also change, right, ma'am? Accordingly.
Yeah, the mean will also change and also see
That will
this I
just
don't know
get
how
cancelled.
those who have traveled by flight might have experienced this before going into England flight. What you do, you usually check your baggage in your house in your whatever weight machine you have. You measure the bag in the weight machine you are having, right? But suppose the airport machine is having a different, there might be some slight changes, right? So how do you usually avoid this error? I don't know how many of you understood the question I asked.
Ma'am, it was disturbing because some noise was coming in.
Yes, ma'am, because
Yes, ma'am.
someone's mic is on.
That
I can't
Jishan
hear you
Ahmad.
properly. Someone's mic
Um,
was unmute.
yeah.
Ma'am, this is coming from Jishan Ahmad, I guess.
Yes.
Yes,
I
ma'am,
don't,
you please tell.
I'm not able to mute him. I tried.
Jishan, can you mute yourself?
I got the option. Yeah, I muted him finally. Yeah, so the thing I was so see, usually when we are checking the weight in two different weight machines, there might be some difference in the weight.
Ma'am, my
So how do
screen
you
is blacked
usually
out.
oh sorry. Yeah. So how do you usually get rid of such errors?
We
You
can check
understand the
multiple
question?
times, madam. We
Ma'am,
can
can you
check
please
many readings.
repeat that question?
See, the question is not here. I'm just giving an instant of what is happening. So, so see, when the way before you go to a airport, so you check the baggage weight in the airport. But before that, you want to make sure that the luggage is within the given limit. So at home or nearby somewhere, you take the weight of that bag. But there might be some difference in the baggage weight, right, in airport at home. So how do you make sure the given weight, whatever you are taking at home, is actually correct? How do you check that?
We can take a margin, madam, like normally -5. So even if the, let's say, weight is a little bit more, that -5 factor will compensate for the weight.
So usually what many people do is that they first check their own weight. Okay. And then they carry the bag in their hand and then check the weight and then take the difference. In this way, whatever the difference is there is that it's going to be the weight. So even if the machine is showing some error, that is going to be cancelled out here. You understand what's going on here? Think about this example later on, maybe. So
Yes,
just a
understood, madam. Yeah.
Yeah. Okay. All right. Okay. So here you see that in this case, variance, whatever is the new variance and old variance, you see that they are not going to be different. Okay. So this also I will leave it to you. So I have given the new data already here. Okay. So the new data is here. So you compute the new variance and verify whether your
Show me previous page for a second, please.
yeah, sure. Yeah.
Not this one. Next to next, I think. Next.
Where here? Before or where are you asking?
Ma'am, the data on which we were discussing actually right now.
You want the data set, right?
Yes.
This one?
Yes, ma'am. Yes. Thank you, ma'am.
Okay. Okay, so I guess we have few more things to cover. So we have to understand next standard deviation. So standard deviation is just the square root of the sample variance. Okay, so standard deviation is just the square root of the sample variance. So what is the standard deviation for the data set we have considered here? So we have already computed this. So taking square root is not going to take much time. 46.4 and 51.56. From here, can you quickly compute the standard deviation?
$6.82.
0.811. It is the population standard deviation.
Okay. So here you see that one advantage of having the standard deviation is that the standard deviation is in the same units as that of the original data, whereas for the variance, it is squared. Okay. So if you see, if the given data is in terms of kilograms, then the variance unit is kilogram squared. Okay. Same way, if you have for the standard deviation, if the data is in terms of kilogram, the standard deviation is also in terms of kilogram, because of which many people also prefer standard deviation. Okay. So there is a small homework I'm going to give all of you. This is not computational, but this is something very important to know. Okay. This I noticed that it is missing in this course, but it is useful for your interviews and all maybe. Okay, suppose you are doing an interview where statistics is given importance, maybe this is an important question to consider, I guess. So the question here, you should all think and maybe we'll discuss the answer on Sunday. Okay. So suppose let us say you have a data set of a particular shop. Okay, the revenue of a shop in India. Okay, so if the revenue as data set from India means it is in INR. Okay. Now you are computing the standard deviation. You don't have the you have the standard deviation in your hand, standard deviation or variance, whatever you have in your hand. Okay, to understand how much the uh, sales vary across maybe let's say a month or whatever. So the same store has a branch somewhere in some other country, and the revenue there is also calculated, and they are giving the standard deviation. Now we are not having the actual data, but we are just having the standard deviation. Okay. So now you see that there is a difference in INR here, and maybe it is in dollars or euros or whatever. Okay. So now the units are different. And so suppose you are having a just one value, you do the conversion and then you check. But suppose there are multiple countries and then you have multiple denominations, and every time if you have to convert to understand this deviation, how are you going to manage this? Is it possible to have a measure where we can get rid of this units completely? Do you understand my question? Is the question clear to everyone?
Ma'am, the last part like of the question was
Okay, so the last part I will repeat. So, is it possible that we can understand the measure of dispersion without having any units in the value which we are getting? Is there something like that which can help us to understand the measure of deviation? That's all. I don't want any units in the value which I'm getting. Is it possible? Okay.
yeah, we can use standard deviation.
Please, don't discuss the answer here. Let everyone think. And those who are not able to think, you have, of course, so many options, ChatGPT or whatever options you have. It's good to even use ChatGPT because you should know the answer. First of all, understand the scenario, think it yourself. I don't think the answer is something you can just think, otherwise, unless otherwise you know. If you can think, that is really great. Uh, Otherwise, just go and check. Okay? You understand the question, right? All right. Okay. So the next topic here is percentiles. So the sample 100p percentile is the data value having the property that at least 100p% of the data or less than or equal to it, and at least 101 minus p percent of the data values are greater than or equal to it. What does it mean? So let's say the very easiest place to understand is the 50%. So we already know that part, right? So from median we will start. What is the median? So median is the point where 50% of the data lies above and below it, right? So that is the 50th percentile, right? So it means what? 50% lies above and 50% lies below. Okay. Now from the same fashion, suppose let us say I'm talking about 25th percentile. What should it mean? So 25% of the data should be below it and the remaining 75% should be above it. That is the position of the 25th percentile. Okay. So it does not mean that the value represents 25%. It just means the position. Okay. How many number of data are below and above it? It's not telling about the value of the data, but the position of the data. Okay. So percentiles tells about the position based on the number of the data, not on the value of the data. Okay. Fine. So now, how do you compute percentiles? To find the sample 100p percentile of a data set of size n, first of all, you need to arrange the data in increasing order. Okay, so if np is not an integer, determine the smallest integer greater than np. The data value in that position is the sample 100p percentile. Similarly, if np is an integer, then the average value of the values in position np and np plus 1 is the sample 100p percentile. Okay, so let's see. It will be clear. So consider this data. So in this data, how many data points are there? There are 10 data points, and they are also arranged in increasing order. Okay. Now here we are considering the first percentile, 25th percentile, 5th percentile, 75th percentile, and first percentile. Now, what is NP we are calculating? And here you see NP is an integer. So if it is an integer, you consider NP and NP plus 1th value divided by 2. So 36.5. Okay, this is the value which lies in the first percentile. So it means only 1% of the data lies below it and everything lies above it. Okay, and then here you see that here you are having 2 point, so 0.25, which is 2.5, which is not an integer. So in this case, what I'm doing, I'm going to take the smallest integer greater than NP. Okay, so it means I'm going to take third one. So smallest integer greater than NP is 3. So I'm taking the third one, so which is 47. So 25% of the data lies below this and 75% data lies above this. Same way for each case we have done. So do you understand how to calculate percentile? Is that clear for everyone?
Yes, ma'am.
All right. Okay. So what else? So what are quartiles? So not all percentiles are interesting for everyone. Okay. So instead of considering all percentiles, there are some specific percentiles which are usually considered. What are those specific percentiles? The 25th percentile, the 50th percentile, and the 70th percentile. And they have special names also: first quartile, second quartile, and the third quartile. Okay, so these are the quartiles we are usually considering. So what are we doing? We are dividing an entire data set. This is the median, which is the 50th percentile. And then the first part again divided into 2. So this is the 25th percentile. And the second part again divided into 2. So which is the 75th percentile. So the entire data is just divided into 4 parts. So here comes Q1, Q2, Q3. This is the minimum. This is the maximum. And all this together gives you the 5-number summary. Okay, so this tells about the data. 5-number summary is a very common thing used in almost all data analysis. If you take any data analysis, so 5-number summary is automatically generated. Okay. Okay, then comes IQR. What is interquartile range? First of all, what is range? Do you all remember? Maximum minus minimum, right? Now, what is this IQR? Okay, it is just Q3 minus Q1. Okay, so IQR is interquartile range. So Q3 minus Q1. Okay, so why IQR? Sometimes what happens, because of the existence of outliers, you know that range is sensitive to outliers. Yes, range is sensitive to outliers. Suppose some data might have too many outliers. Okay, so in that case, so to understand the dispersion, instead of considering the range, you prefer an IQR, the interquartile range, because you know that the outliers are either going to be present here or here in the extreme part, right? So you can get rid of this extreme part and then you can just proceed with the IQR. Do you understand the purpose which I am telling? Why IQR might be used instead of range? Because range is sensitive to outliers and hence IQR is preferred over range when there are too many outliers. Clear? Okay. So now in the example which we have considered here, what is Q1, Q2, Q3? What
Ma'am,
is Q1?
median of the lower half is Q1 and
So
Q2 is
25th percentile is your Q1, right?
Yes, ma'am.
And 50th percentile is your Q2. 75th percentile is your Q3. Okay, fine. Okay, so I guess we are at the
that means
end of the
IQR.
content.
One question, please. IQR
Yes,
is not affected by outliers, right?
yes, yes. Usually all the outliers are in the extremes, right? So before the 25th and after the 75th percentile. So if some data is going, some outliers are going to be there within 75, that should not be, it cannot be considered as outlier at all. Okay. So in fact, there are some specific formulas to see what are the outliers based on the IQR value. Okay. So that is not
Ma'am,
used
that is
here.
1.5 plus
Yeah, yeah.
IQR and
Yeah,
1.5
yeah, it is
point.
there. We have, I guess it is not used in this course. I guess at least in this week, I did not notice that formula used anywhere.
And some
Okay.
questions were there based on that.
Okay, maybe in the Sunday session, I will go through it
Okay.
and see if it is used, then we will check that.
And
Okay.
also, ma'am, that box plot,
Box
can
and
you?
discuss. Yeah, we will discuss problems on it. Okay.
Okay. Okay, ma'am.
Yeah, fine.
Ma'am, I have
Hmm.
just a question.
Yeah.
This, ma'am, this uh, standard deviation, that variance, all these things are affected by outliers.
Yes, there is definitely because you see mean is affected by outliers. So variance and standard deviation use as mean and hence they are also affected by them.
Okay. Okay.
Yeah. Okay.
Okay, ma'am. Thank you.
Okay. So what are the topics we have seen in today's session? So the topics we have seen are we have seen the frequency table for discrete data and continuous data, right? And we have seen the graphical summaries, histogram, stem and leaf plot. Okay. And then we have also seen the different measures of central tendency, measures of dispersion, and then we have seen what are called percentiles, right? So here, just let me say a quick check on things. So what is the difference I told between histogram and bar chart? Can anyone tell?
Ma'am, there is no gap
Okay.
in
Yes.
Yeah,
histogram.
In
in histogram, there
histogram,
should not be any gap. It represents continuous data. All right. Mean median mode. Which is more sensitive to outliers?
Mean is
Ma'am,
sensitive.
mode and mean.
Mean, then
Mean is
Mean.
sensitive.
Yeah, mean is more sensitive to outliers, right?
Ma'am,
Okay.
how? Why not mode?
See, suppose let us say the data set which we considered 1, 2, 5, 7, 10, 11, something like this is there. And then I'm having 1, 2, 5. This is actually having no mode. Maybe I will take an example with the mode. 5, 6,
Oh, okay, okay. Okay, ma'am,
8.
got it.
Got
one
it, right?
value
Yes,
on
ma'am. Yes.
only one large value can't be a mode, ma'am. That's
Yeah,
why.
so this is an outlier if you consider, then you see that the mode is not affected, right?
Yes,
Yeah,
ma'am. Yes, ma'am.
yeah.
But mode
Okay.
can be affected, right?
Mode, see, when there are too many outliers of the same value, suppose the same 18, 18, 18 is coming, it may be affected, but it is a very rare case.
Okay, okay. Okay, ma'am.
Yeah. Okay,
Ma'am,
so
I have one
any
confusion.
yeah,
If too many outliers, then it can't be outliers, same value. If too many outliers of the same value, I think
it
then
is possible. It is
consider
possible.
it as the outliers.
It is possible, but how many numbers it matters. But see, for example, let us say in a company there are like thousands of employees, but only 10 managers or 10 directors are there who are in the very top position. Okay, so that 10, whether you consider too many, that depends on the scenario. That 10 definitely are going to be the outliers when you are taking their salaries. Compared to everyone else, the directors are going to have very high salary, right? So their salaries are outliers, right? It is possible, but how many and what is considered too many depends on the scenario. Okay?
Okay.
Okay, ma'am, got it.
All right. Okay, so are there any questions from today's session? Was the session useful for everyone? I hope it was useful. And we will again look at more problems on Sunday session. I was not able to do many problems today, but on Sunday definitely we will be doing a lot of problems, many problems from your PA, AQ. AQ usually are covered in TA session, right?
Yes, ma'am, AQ is covered.
So then we will do something based on PA or maybe GA also. Okay?
Yes,
Okay,
ma'am.
ma'am.
I had one doubt about the graded assignment, the marks that are allotted. If you could tell me something about it.
GA, actually, this term, if you look at the grading policy, there are not any marks specifically for submitting your GA, but I guess the bonus marks matters.
Yes,
That's
yes,
it.
yes. That
Bonus
is there.
marks and
But
eligibility.
yes, ma'am. It's just that it's reflecting a wrong score on my dashboard. That's all I'm like. I know it's not calculated in the final equation, but it's still a matter of concern that if it's being reflected that way, it
Have
should
you
not be.
sent any mail to the discussion forum?
Yes,
Ma'am,
ma'am.
this
I
is
think
happening for me also.
yes,
Oh,
ma'am.
okay. Okay. I also saw something, but I thought it is already addressed. If it is not
Yes,
addressed,
yes,
I'll.
ma'am. It was addressed in a way that they said it will not be used for evaluation, but then
Oh, yeah.
that should also reflect on the scorecard of
I understand.
wherever the
I
scores are
understand.
updated.
I
Yes, ma'am.
understand that. Okay, I'll look into it. Yeah.
Thank you so much, ma'am.
And there was one thing I wanted to say. I don't know whether that person who joined for the week 2 doubt session is there. So this person asked a particular doubt on an AQ which asked a question about the Pareto chart. Are you sure the person who were asked the doubt regarding the Pareto chart? Okay, then maybe during the revision session I'll cover it up.
Mom, where do we get the class notes?
As usual, so you have some drive where you have all the notes, right? I will put there only.
Okay, ma'am. Thank you.
Okay.
Thank you, ma'am.
Okay, ma'am. Thank you
Okay.
for the session.
Thank
Thank
you. Thank you.
Thank you, ma'am.
Thank you so much.